Hi there, Serdar Yeghilal for InfoWorld here. In this episode of Smart Rust, I'm going to look at one of Rust's most powerful features, the option type. The option type lets you have an elegant way to express a common but tricky programming scenario. This is when you have a variable that could be some value of a given type, or it could be nothing at all. In languages like C, we have the concept of null to express a non-existent value. But it's too easy to write code where a null value would get used instead of a non-null value at runtime, and that would result in a crash or a subtle error. With Rust in the option type, though, you get this kind of checking at compile time. Issues with nullable types, as they are called, get flagged by the type system before they ever make it into production. Here's a simple example of the option type in action. I have here three variables, x, y, and z. X is a plain old 32-bit integer, the number 32. Y is an option type, which could either be some 32-bit integer or none. In this case, we're saying it's some 32-bit integer, which is why we're using the sum keyword to construct that. And in this case, that integer is the number 16. With Z, we're explicitly declaring the type. We're saying it's an option that could be a 32-bit integer, but for now we're setting this wrapped value to none. Next, we're going to perform math on each of these values and print the results. But we can't take x, which is a 32-bit integer, and add it to y, because y is not an integer. It's an option type that could be a 32-bit integer. If we try to do this, the compiler will complain. So how do we take the value that's wrapped inside y and work with it? Well, the answer is by way of a family of methods available to option types called, appropriately enough, unwrap. Unwrap takes the value inside an option type and makes it available for use. It unwraps it. So if we want to add x to y, we take x and we add it to the results of y.unwrap. Now, that seems straightforward enough, but here's a subtle little issue. One of the things option is supposed to give us is the ability to work elegantly and safely with values that might not exist. So if we just do unwrap on a none value, what's going to happen here? In this print statement, we're trying to do just that. We're taking z, which has been set to none at this point, and we're trying to add the unwrapped value to x. And this doesn't get flagged at compile time, because z could be an integer. So if we uncomment this out, and we run this code, the program will crash. We can't add none to an integer. The whole thing fails. So the problem is that this is the kind of thing that really should be flagged at compile time, not runtime. This sort of defeats the purpose. Well, if we look at the documentation for unwrap, they don't recommend using it except in circumstances where you know exactly where you're unwrapping. The vast majority of the time, you're going to want to use one of a number of other unwrap methods. And here they are. The first is unwrap or. And what this does is it tries to unwrap what's in the option type, and if we get none, it will substitute in another value for the wrapped type. So here, with this unwrap or, we'll use 1, a 32-bit integer, as our substitute value if z is in fact none. The next thing that we can do is use unwrap or default. This is the same thing as unwrap or. It substitutes a value when there's none, except that the value that we're supplying is the default value for whatever the wrapped type is. So for a 32-bit integer, that value will be 0. And finally, we have unwrap or else, and this lets us use a closure, an expression, to supply a value. And that's what this double bar here syntax indicates. That's a closure. So the value supplied here will be x plus 1, and the value of x will be captured from whatever the state of the program is at that moment. Closures are something worth going into in a separate video in detail, so I'll set that aside for now. Last of all, I have here a case where we set z to an actual value, a sum 64. We're not setting it to 64 directly because z is not an integer. It's an option type that could contain an integer. So again, we use sum to express this. Now let's run this code and look at the results. First we print x, and that's, as you can see, 32. We then use unwrap to get the value of y, 16. Add that to 32, we get 48. We then use unwrap or to get a default of 1 from z, and that yields 33. Next, we use unwrap or default to get 0 from z, so that yields 32. We then use unwrap or else to get x plus 1 from z, and that yields 65. And then finally, we set z to sum 64, which yields 96. So these are all the different ways that we can unwrap something and work with the values within, and also elegantly work with them when they contain none. There's a couple more things that are worth walking through here. The first is there is another unwrap method named unwrap unchecked. And what this does is it unwraps an option value without performing any safety checks on it. And that is faster, but it's at the expense of program safety. One of the things Rust emphasizes is safety. And since this is an unsafe operation, we have to explicitly declare this. We have to wrap it in an unsafe block, something Rust forces us to do in situations like this. Unsafe and all of the ways that you can work with it are worth exploring in a later video, but for now, this is the basic idea. If we want to use unwrap unchecked, we have to put it in this declaration. But if we try to run this, as you can imagine, it will not work because we cannot add none to X, as we've seen before. Another thing you may try to do is use unwrap to swap in something from a different type. For instance, in this last bit here, I have an option value that contains a string, and I try to use unwrap to swap in an integer using unwrap OR. Now, there are all kinds of reasons why this doesn't work. First of all, unwrapping an option for a string is only ever supposed to give us a string or none. So we would be able to add this to an integer anyway. Second, and more importantly, the default that we supply for an unwrap operation has to be the same type as the wrapped type. So substitutions like this, where we try to swap in something from a different type, are violations of Rust's type system. This won't compile at all. So don't try to do this. So to sum up, the option type in Rust gives you a way to encode values that are either some particular type or nothing at all in a way that's handled safely by the type system. You can obtain the value inside an option type with an unwrap operation, which lets you substitute in a default value if your option value is none. But you cannot use this to perform end runs around type safety. You'll either get results that won't compile, or you'll expose yourself to runtime errors you don't want, or you'll have to use unsafe blocks. And these are all things you probably started using Rust to avoid in the first place. So that's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the Tech Talk channel on YouTube. And for more smart Rust and more dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.